Hello, welcome back. Today we're going to be talking about solving linear systems using substitution. The objective is that by the end of this video, you should be able to solve a linear system by using substitution. As a reminder, substitution means that we're going to replace one thing with something else. And to solve a linear system, the goal is to find an ordered pair, x, y, that makes both equations true when we substitute the x and the y back into the equation. So if we have the following two equations, we can use substitution to find a solution to the equations. So our equations are y equals x minus 5 and 2x minus 3y equals 6. So we know that y has to be equal to x minus 5 for both equations. We also know that 2 times x minus 3 times y is equal to 6. Substitution again means that we replace one thing with another. So y is equal to x minus 5. That means that in both equations y has to be equal to x minus 5. So I can take x minus 5 and I can substitute that entire expression in for the y in the other equation. This will give me 2x minus 3 parentheses, and I'm going to substitute in the x minus 5. Now again, the reason I can do that is because y is equal to x minus 5, and I could put that x minus 5 in for the y into the other equation. Now all we have to do is solve the equation for x. Since we only have one variable, we can get that variable by itself. To do this, we first need to simplify our left-hand side of the equation. So I'm going to distribute the negative 3. This will give me 2x. Negative 3 times x is a minus 3x. Negative 3 times negative 5 is a positive 15, is equal to 6. I can continue simplifying the left-hand side of the equation by combining my like terms. 2x and negative 3x combine to give me a negative 1x plus 15 is equal to 6. I still need to get x by itself, so I can subtract 15 from both sides. We're going to rewrite the equation up here. Negative 1x plus 15 is equal to 6. So I subtract 15 from both sides, and I am left with negative x, or negative 1x rather, is equal to 6 minus 15 is a negative 9. To get x by itself, I divide both sides by a negative 1 to get rid of that negative in front of the x. And this will leave me with a positive x, because a negative over negative is a positive, is equal to a negative 9 over a negative 1 is a positive 9. So we've solved for our x value by substituting the y into the other equation. The difficulty we're going to face at this point is that we now have an x, which is 9, but our goal is to get an x and a y. Since x is 9, we can actually substitute x into either of the two equations to solve for y. I'm going to choose the equation y equals x minus 5 in order to find my y value. So I know that since x is equal to 9, I can substitute again the 9 into y equals x minus 5, leaving me with y is equal to x, which we said was going to be 9, minus 5. 9 minus 5 is 4, so our y value is 4. And this should be the solution to our linear system. Now what we're going to do is we're going to check to make sure that our solution really is a valid solution by substituting that solution back into both equations. So I'm going to go ahead and erase everything I've got here. And I'm going to substitute in the 9 and the 4 in for x and for y. This will leave me with, again, the 9 in for the x, and the 4 in for the y. Will leave me with 4 is equal to, our x is 9, minus 5. 4 is equal to 9 minus 5, which is 4, so our solution checks out for the first equation. We'll now check it into the second equation. 2 times the x value, which is 9, minus 3 times the y value, which is 4, better be equal to 6. So 2 times 9 is 18, minus 3 times 4 is 12, is equal to 6. 18 minus 12 is 6. 6 equals 6, so our solution checks out for the second equation too. We've now shown that the solution we found by substitution is indeed a solution to the linear system. Go ahead and try to solve this system on your own, pressing pause, and when you're ready to see the answer, please press play. I went ahead and got you started. In this case, we know that x is equal to 2y minus 4, so we can substitute 2y minus 4 into the x in the other equation, giving us 6y is equal to 2 times the x value, and the x value was 2y plus 4. And then we subtract 12. I simplified the right-hand side of our equation, and I was left with 6y equals 4y minus 4. I then needed to get all my y's on the same side of the equation, so I subtracted 4y from both sides, giving me 2y equals negative 4. Then I divided both sides by 2, giving me y equals negative 2. Now this gave us half of our solution, just like it did in the previous example that we worked. We end up our y value being negative 2, but we do not have our x value. So what we can do is we can actually substitute the y value of negative 2 into one of the equations, and then we can solve for solve for x. So we know that x is equal to 2 times y, which is negative 2, plus 4. We give you just a little bit more room to see the work written out. So we have again, x is equal to 2y plus 4. So x is equal to 2 times y, which is negative 2, plus 4. So x is equal to negative 4 plus 4, which means x is equal to 0. So our x value is 0 and our y value is negative 2. Now that we've solved for our x and our y value, we found the solution to our linear system. We want to check our solution. Go ahead and pause the video, check your solution, make sure it works out, and press play when you're ready to see the answer. I checked the solution of 0, negative 2 into both of the equations and found out that I had a true statement at the end of both equations. In other words, 0, negative 2 does check out, so it is indeed a solution to our linear system. We're now going to solve the following linear system using substitution. Now, if you look at this system, you'll notice that it's different from the other systems. In this system, none of the variables are by themselves. So what we need to do is we need to get one of the variables by itself in one of the equations so that we can substitute that variable into the other equation. Let's choose a variable in one of the equations to get by itself. I'm going to choose to get the y by itself. Because to get this y by itself, all I need to do is subtract 3x from both sides, giving us negative y equals negative 3x plus 1, and then I'm going to divide both sides by negative 1, giving us a positive y equals a positive 3x. Positive 1 over negative 1 is a minus 1. Now that we know that y is equal to 3x minus 1, we can substitute that y value into the other equation. This will give us 8 is equal to 3x minus 2, and our y is 3x minus 1. So we're going to simplify the right-hand side of the equation by distributing the negative 2. This gives us negative 2 times 3x is a negative 6x. Negative 2 times a negative 1 is a positive 2. Simplifying further, we combine our like terms, the 3x and the negative 6x, giving us negative 3x plus 2. We're then going to continue solving for x by subtracting 2 from both sides, and we're left with 6 equals negative 3x. We can divide both sides by negative 3, giving us negative 2 is equal to x. And we've solved for half of our solution to our linear system. So we know that x is negative 2. Now all we need to do is to find the y value. Well, the convenient thing is we've already solved for the y in our first equation. So I can actually take this negative 2 and substitute it in for the x of that equation I got earlier. This will give me y is equal to 3 times negative 2 minus 1. So y is equal to 3 times negative 2 is negative 6 minus 1. So y is equal to negative 7. So our solution should be negative 2 comma negative 7. Please go ahead and pause the video, check your answer, plus play when you're ready to see the work out. When I checked my solution, I found out that it worked in both equations. So negative 2, negative 7 is indeed our solution. Go ahead and try to solve this linear system on your own. Before you get started, you might want to choose the variable to get by itself that will be the easiest to solve for. In other words, we wouldn't want to choose the x or the y in this first equation because we would have to subtract and then divide. If you look at the second equation, getting the x by itself will be real easy because all we'll have to do is subtract 3y from both sides. And then we can substitute back into the other equation a lot easier. In other words, I'm suggesting that you solve for x in the second equation first, and then substitute, and then solve. Go ahead and work this problem out, pressing pause, and when you're ready to see the answer, please press play. I went ahead and got x by itself in that second equation by subtracting 3y from both sides. That gave me x is equal to 3 minus 3y. I substituted that 3 minus 3y into the first equation, and when I solved it out, I got y was equal to positive 11. Then I can solve for the x value again by substituting that 11 into our solve for equation that we had at the beginning. So we can get x is equal to 3 minus 3 times whatever y was. In this case, y was 11. Leaving us with x is equal to 3 minus 33, so x is equal to negative 30. So our solution then should be negative 30, comma, positive 11. Go ahead and check the solution on your own, pressing pause. When you're ready to see the answer, please press play. I found out my solution did indeed check out, so negative 30, comma, positive 11 is our solution to the system. It's important that you work this example out because something weird will happen to the solution in the end. Go ahead and try it on your own, pressing pause. When you're ready to see the answer, please press play. I went ahead and solved it out to this point, and I got negative 4y plus 10 plus 4y equals 10. Negative 4y plus 4y, when we combine them, gives us no y's at all, and we're left with 10 is equal to 10. Now, 10 always equals 10. So we're left with a bit of a weird situation here. If you were to solve the second equation out, you would find out x is equal to 2y minus 5. In other words, these equations are exactly the same even though they look different. And if you remember from graphing, if the equations are the same, there's infinite solutions. How you can tell by using substitution that there are infinite solutions is when all of the x's and y's go away and we're left with just one number equal to the exact same number. So anytime you're left with something that is true, a number equal to a number, you know that there are infinite solutions. Go and work this one out on your own too, and again, something different but also weird is going to happen with this one, like it did in the previous one. Go ahead and pause the video and press play when you're ready to see the answer. When trying to solve the equation, you might have noticed that the 6x and the negative 6x canceled out, leaving us with negative 14 equals 5. Negative 14 does not equal 5. It's not a true statement, and we got not a true statement when solving. So when this happens, you know that there's no solution. If you were to solve for y in that second equation, you would have gotten the same slope for both equations, but different y-intercepts. Same slopes, different y-intercepts means that there are no solution. Again, the way that shows up in substitution is all the variables go away, leaving you with one number equal to a number, but they're not actually equal.